Welcome to Go Figure School of Mathematics. I'm glad you're here. Today is lesson 1 of Algebra 1, the language of fractions. Now first, before we get into this, if you haven't seen the intro to this course, please go back and watch that. It'll be lesson 0 of Algebra 1. So before we even begin algebra, we have to be completely comfortable with the language that fractions speak. Today we're going to build on what you already know about adding and subtracting fractions. Before we learn anything new, let's see what patterns we rediscover together, and then we'll stretch those patterns a little further. By the end of today, you will be able to add and subtract fractions and mix numbers with confidence, even when the denominators don't match and even when we have to borrow. And you'll use fractions to measure the parts of a line segment. So, what do we already know? So look at this problem, 2/9 plus 5/9. What do you notice about the denominators? Right? They're both 9. We're dealing with ninths. So our pieces are the same size. So in order to add them, all we need to do is add the numerators, the top numbers. So 2/9 plus 5/9. We just add our numerators and we get 7/9. And here's a subtraction problem, 7/8 minus 3/8. Again, you'll notice that the denominators are the same. So all we need to do is subtract our numerators. 7 minus 3 is 4. So we're left with 4/8. Now, what should we do? Can this 4/8 be rewritten any other way? Right, we need to reduce this because we can turn this into 1/2. 4/8 is the same as 1/2, and we always want to reduce our fractions when possible. And here's another example. These are mixed numbers that we're adding now. And what do we do when we add mixed numbers where you have whole and you have fractions? So we want to add the whole numbers separately and add the fractions separately. So in this case, we have If we add our whole numbers, we have 2 plus 1, which is 3, and then we have 1/5 plus 3/5, same denominator, so we're just adding our numerators. So our final answer is 3 4/5. Here's a simplification, simplify 6/8. That just means how can we reduce this fraction more? What factor can we take out of both 6 and 8? Well, they're both divisible by 2, so that's how we would reduce that. Divide both by 2, we get 3/4. Is 3/4 the same as 6/8? Yes, so that's how we know that that's an equivalent fraction in the lowest terms. Now for something new. So what do we notice about these two numbers, 1/2 and 1/3? Right, the denominators are different. Can we just add the two fractions together like we did before? Can we add 1/2 and 1/3 as it is? We would get 2/5. But does that make sense? 2/5 is less than 1/2, which we were adding to, so that doesn't make sense. So what do we need to do in order to add these fractions? We need common denominators, right? What multiple is the same for 2 and 3, and what's the lowest one? We're trying to find the lowest common denominator between 2 and 3. Well, that would be 6. So let's rewrite these fractions. 1/2 would be 3/6 if we multiply both the numerator and denominator by 3. And then 1/3, we need to multiply both the numerator and denominator by 2. So we get 2/6. Now we have common denominators, and now we can just add our numerators. So we get 5/6. So again, just adding the denominators wouldn't make sense. We would get 1/2 plus 1/3 equals 2/5. That is smaller than 1/2, which is impossible. We can't do that. So the basic rule to add or subtract fractions, we want to first give them the same denominator, and preferably the least common denominator. You just want to work with like the lowest numbers that we can. And then we add or subtract the numerators and keep the denominator the same. Why does this work? Well, because we have equal size pieces that can be counted together. Different size pieces can't be combined directly. That's why we need to change them into similar sizes. And you can think of maybe like a pizza. Let's say we had a pizza cut in half, and that's our fraction of 1/2. And we need a common denominator of 4. We could split this pizza into fourths if we cut it again. And I'll just do this so we can easily see that. Okay, so now instead of 1/2, we have 2/4. So it's the same amount that we're talking about, it's just written in different terms. And when do we want to use it? We want to use it anytime our denominators are not already the same, right? Because that's the way that we can add or subtract. And you can always check your answer, estimate. Is your answer sensible? Does it make sense? Well, our answer to our last problem was 5/6, which is close to 1, and that seems reasonable for a half plus a third. Okay, here we have subtraction with different denominators. Again, so are the denominators the same? No, we need a common denominator. So our lowest common denominator here would be a multiple of both 3 and 4 would be 12. So let's rewrite these as 12ths. So we're multiplying this first fraction by 4/4. So you're going to get 8/12. And then our second fraction, we're going to be multiplying by 3 to get 3/12. Now we have common denominators and we can just subtract our numerators, 5/12. And then the second question we should ask ourselves is, can this fraction reduce? And no, this one can't, because 5 and 12 do not have common factors. So that was our reduced fraction. So again, the very first question for any fraction, when you're adding or subtracting, are the denominators the same? Okay, so here's a new concept, borrowing with mixed numbers. So if we look at we're subtracting here, and we want to subtract our fractions first. If you look at 1/4 minus 3/4, do we have enough fourths to subtract from? Right? We can't take away 3 from 1. And I'm going to just rewrite this because it might look be a little easier to see when we write it vertically. And remember, when you first learn subtraction, what do you do when there's not enough to subtract from? Right? We would borrow from the next place. So we can borrow one of these whole numbers. So we'll be left with 5. And that one that we borrowed, we can split up into pieces. We'll split it up into fourths. So that would be 4/4, but we want to add it to this 1/4 that we already have. So we're going to be left with, I'm going to cross that out and I'm going to change that to 5/4. And now we have enough to subtract. We can do 5/4 minus 3/4 equals 2/4. And then we have 5 minus 2, which is 3. Okay, now, are we done with this problem yet? No, because our fraction has to be reduced. We can reduce 2/4 to 1/2. So our final answer should be 3 and 1/2. Oh, and I have all these steps here. So again, 1/4 is smaller than the 3/4, so we can't subtract yet. We're going to borrow, take away 1 from the 6, and that whole is 4/4. Then you add your 4/4 to your 1/4 that you already had. So it becomes 5 and 5/4. Then we can subtract just like we did. All right, here we have a line segment. So just to kind of review, you might see a diagram like this that represents a line with some points on it. And we know that it's a line because it has arrows on the end to indicate that it goes on in both directions forever. That's a line. But here we have a line segment where it doesn't have arrows that show that it goes on forever. It's just from point to point. And that is called a line segment. It's a part of a line. And you'll notice there's one big line segment from A to C. And then there's two smaller line segments from A to B and B to C. And so we have what's called segment addition, where if we could add the lengths of AB, the segment AB, plus the segment BC, gives us the whole length of the segment AC. And that's how we note them. It's just the letters that represent the points, the endpoints of your segment. So the whole segment from A to C equals the sum of its parts, AB plus BC. So a missing part, let's say that we know the length of the whole thing, and we know maybe one of the parts, but we don't know the other. We're trying to find the other. We can always subtract the whole length and minus the one part that we know to get the missing part. So let's show this as an example. So another thing to do when you get problems like this, it is very helpful to actually just draw a quick diagram. So we're talking about segment AC. So I'm going to label my 2 points AC. And then we have another point B that's somewhere in between. Doesn't really matter. We don't need to be to scale. Just so you can visually see. So segment AC is 7/8 of an inch. Segment AB, so from here to here, is 1/4 of an inch. And we need to find the length of segment BC. So again, we know the whole thing. So we're going to have to subtract fractions here. The whole thing is 7/8. And we know this part, 1/4, so minus 1/4 of an inch. And we're trying to figure out what that equals. So here we have subtraction with fractions. First question, what do we notice? The denominators are not the same, so we need common denominators. So let's rewrite this. Our common denominator is going to be 8 here. So 7/8 minus 2/8. Then we're just subtracting our numerators to get 5/8. So 5/8 of an inch is segment BC, and we can even write that over here because we were trying to find BC. So let's write that here. BC equals 5/8 of an inch. So again, just reiterating, a missing part equals the whole minus the known part. And there's our answer, 5/8 of an inch. Okay, so I want you to try these as before we go on together, and let's see. Remember to always ask yourself, are the denominators the same? Change them to have the lowest common denominator. And then add the numerators. Okay, so here we have different denominators. Our lowest common denominator is going to be 10. So we're multiplying this first fraction by 2/2, so that gives us 4/10. Our second fraction, we're multiplying by 5/5, so that gives us 5/10. Add them together, our final answer is 9/10. Subtraction of mixed numbers. And sometimes, again, it's easier to rewrite this vertically. And we can see we have the same denominators, no problem there, but we don't have enough to subtract from. So we're going to borrow 1 from here to change that to 3, and that 1 that we borrowed is going to turn into thirds now, 3/3. So we'll have 3/3 plus 1/3 is 4/3. So I'm just going to rewrite that there. Now we can subtract. 4/3 minus 2/3 is 2/3. And then 3 minus 1 is 2. So 2 and 2/3. And then as our fraction in lowest terms, yes, it is. Okay, here's a segment problem. Again, we can start with drawing a segment, points A, C, and B. This just helps us visualize. And we're asked to find the length of segment AB. So you can rewrite this as segment AB is going to equal the whole thing, which is AC, and subtract the part that we know, which is BC. And then we can substitute our numbers in here. So AC was 9/10 of a centimeter, and BC was 2/5. Okay, we need common denominators, which is 10. So we'll do 9/10 minus 4/10, which equals 5/10. And can we reduce this? Yes, we can. They're both divisible by 5, so that's going to end up being 1/2. So segment AB equals 1/2, and we always want our units. We're talking about centimeters, so 1/2 a centimeter. Okay, here is some independent practice for you to do on your own. You can check the quiz on this video and put in your answers there, and hopefully you get them all right. If not, see if you can figure out where you went wrong, or go back and watch the video. And just remember to check your denominators first, borrow when the numerator is too small, and always ask, can I reduce? So go ahead and pause the video and work on those problems. Okay, and here's just a real world connection. Where do fractions show up every day? Maybe you can list a few ideas of your own. When do we see fractions in everyday life? So here are some that I came up with. Cooking and baking, that's a huge one. You have recipes, you can combine fractional amounts. You're always dealing with halves and thirds and quarters of a cup or teaspoon. So lots of fractions in cooking and baking. There's construction and carpentry. When you're measuring things, you need to be exact. You might have parts of a foot or parts of an inch. And also measuring distance. So you could, this would be where segments come into play. Combining segments of a route, like if you have 2 destinations, you know the distance to one, and you know your total distance, and you're trying to figure out what's the distance between the other 2 points, things like that. Okay, today's summary, the language of fractions. So number 1, you want same size pieces. So unlike fractions, need a common denominator before adding or subtracting. When you're borrowing, if the top fraction is too small, you want to borrow a whole and rewrite it as a fraction. For segment addition, the whole equals the sum of its parts. And you can always find a missing part by subtracting a known part from the whole. And we always want to reduce. Check your answer. Can it be rewritten in lower terms? So next, we'll carry this into signed numbers and soon variables, the famous part of algebra. So go ahead and do your practice worksheet, and go figure.